Hello guys, welcome to Brilliant Qatar. Here we have the chapter Amines. Amines, the chapter we are discussing the most important competency based question for your upcoming 2025 chemistry board exam. Let's go to the question number 1. The reaction of an arene diazonium chloride. What is an arene diazonium chloride? You know, benzene diazonium chloride. Yes. This is our aryl diazonium chloride with aniline. With what? Aniline. With aniline, right? With aniline, NH2. In an acidic medium. Yes, in an acidic medium. Gives a colored compound. Yes, we studied the reaction. Which of the following occurred during the reaction? Can you tell me, dear, what is the answer for this one? You studied the last part of the chapter called azo-di coupling reaction. Coupling reaction. Benzene diazonium chloride, when treated with a phenol, we get a orange dye. With aniline, we get a yellow dye. You know the structure of the product also. Benzene, that we have a N double bond N, again one phenyl ring on which we have NH2. It's called para-amino-azobenzene as having a yellow dye. What is the reaction called? Diazo group is obtained. It's a coupling reaction, azo-di test. Okay, so benzene ring is replaced, no. Nitrogen is displaced, no. Nitrogen is there. Diazo group is obtained, yes. Diazo to nitrogen, diazo. And amino group is replaced, no. Next one, which of the following is true about the solubility of ethylamine? What is ethylamine? CH3, CH2, NH2, ethylamine and aniline. Ethylamine and aniline, which is correct. Let's see. Aniline is soluble in HCl. Yes, it is correct, right? Aniline is what? Aniline is soluble in HCl. We know in water it is less soluble due to the benzene ring. But in acid, amines are soluble. So what happens if you treat it with HCl, dear? You know, aniline, take this H plus, form anilinium ion, right? Anilinium ion it forms. Soluble one. So it is soluble. So aniline is soluble in HCl because aniline react with HCl, form soluble salt. Which one? Anilinium ion. Both are insoluble in HCl. No. Both are soluble in water. You know, aniline is not soluble, but aliphatic amines are, lesser amines are soluble in water. So that's also incorrect. Ethylamine is insoluble in water. No, ethylamine is an aliphatic amine. You know, primary amines are highly soluble in water. So that's statement also wrong. Only aniline is soluble in HCl. Next. During an activity session, the teacher kept some pieces of paper in a box in which the names of chemicals were written. The teacher then asked 4 groups of students, okay, group 1, group 2, group 3, group 4, to select the appropriate pieces, paper with the name of chemical used to prepare para-nitroaniline. So what is the product you want here? Para-nitroaniline. This is what our para-nitroaniline. The 4 groups have selected pieces of paper as follows. Ready? Question: which group or group of students have selected it appropriately? So in which generally we can say group 1, group 2, group 3, group 4. Who did the correct reaction to get para-nitroaniline is the question. We studied a reaction aniline, right? Aniline. Aniline is a very strong ortho-para directing group. So we will protect the aniline group, NH2 group, for a while by the process acetylation. Acetylation. What is acetylation? Either we can use acetic anhydride, even acyl chloride also. Acyl chloride. Anyone can be used it. What it become? It become benzene with NHCO, CH. This is our acetanilide. You know, amines are strong ortho-para, amides are weak ortho-para. Then we will add what? Nitro group, which is what? HNO3 and H2SO4. What becomes that NH and COCH3 comes and NO2 will be here. Finally, on acid or base, when you treat it, you will get your NH2 and NO2 back. This is actually the reaction we studied. Yes. Directly on aniline, if you do nitration, what happen? You know, ortho, meta, para, all kind of things can form. If you want para, we have to protect the aniline by acylation process. That's acetic anhydride or acyl chloride can be used. So check it which is correct. Concentrate H2SO4 HNO3, yeah, nitrating mixture. acetic anhydride aniline. Yes, it will give you the same product para-nitroaniline. Aniline directly on nitration, you will get ortho, meta, para, all products. So this is not correct. Constant HNO3 and pyridine aniline. No, acylation or acetylation not happened there. Constant HNO3, H2SO4 aniline, acyl acetyl chloride. Yes. So acetyl chloride or acetic anhydride must be there. Then only that protecting NH2 group is possible, and you will get only one nitro group. So group 1 and 4 did the correct one. Group 1 and 4 did the correct one. Good question. Next one. Aniline. Okay. Aniline on heating with the chloroform and alcoholic KOH. Can you recognize what is the reaction? Carbylamine reaction. Yes. Aniline. What is aniline? Benzene with NH2. What is chloroform? CHCl3 and alcoholic KOH. What has happened here? NH2 become NC isocyanide and you will get KCl and we have which one? H2O. Ready. Question is twisted one. Making which of the following changes in the reaction would still produce the foul smelling product? What they're going to make some changes, okay, but still the same product where it is getting. Let's see, replacing aniline with the ethylamine. Yes, you will get carbylamine. You know, carbylamine test is given by primary, aliphatic and aromatic. Yes, it's a primary aliphatic amine. It will give foul smell. So even if you shift aniline by ethylamine, you will get the foul smell. Replacing chloroform with a carbon tetrachloride. That's not possible. Chloroform must be there. Okay. Now, replacing alcoholic KOH with alcoholic NaOH. No issue. There should be a strong base. That's all. NaOH or KOH can be used. So here also P and R. Only P and R where you will get the foul smell again. Next question here. Benzylamine is formed when? What is benzylamine? Benzene with CH2NH2. This is called benzylamine. Is formed when one of them treated with a sodium amalgam in the presence of ethanol. Sodium amalgam in presence of what? Ethanol. Where you studied this one? Sodium amalgam, not zinc amalgam. Okay, not that. Zinc amalgam is our clemenza. This is sodium amalgam. That is from where? That is from where? A cyanide. We studied cyanide on reduction with the sodium amalgam in ethanol or hydrogen with the nickel. We get CN become CH2NH2. That is what? Benzonitrile or cyanobenzene. Benzonitrile. Cyanide on zinc, sodium and sodium amalgam and ethanol. We get amines. Next one. Which of the options correctly identify the amount of ammonia and alkyl halide? What is the reaction? Ammonia and alkyl halide, that's our ammonolysis. In ammonolysis, two important data we studied here. What is ammonolysis mean? You know the demerits of ammonolysis and all. We studied if we use ammonia and alkyl halide RX, right? If ammonia in the beginning is excess, right? Excess. If ammonia in the beginning is excess, you will get primary amine as a major product. What happens if haloalkane is excess? If haloalkane is excess, quaternary will be the major product we studied. Correct or not? Primary amine, you know, during ammonolysis, we'll get primary, secondary, tertiary, quaternary amines. But if you use excess ammonia in the beginning, you will get primary as major product. Excess haloalkane in the beginning, you will get quaternary as the major product. Let's check it. Where question which is correct or incorrect here? They are asking which of the option correctly identifies the amount of ammonia correctly. Equimolar ratio of ammonia and alkyl had equal amount they used. The secondary amine is the minor and tertiary amine is the major product. No. Large excess of ammonia, quaternary ammonium salt is the only product. No. Large excess of ammonia, primary amine. Yes, large excess. Excess of ammonia if you use in the beginning, primary amine as the major product. So N will be the answer. Then two statements are given below. Let's see what is the assertion given. What is assertion? Beside ortho and para nitroaniline, nitration of aniline in an acidic medium also give meta derivative. Yes. Yes. We studied aniline is a very strong ortho para directing group. If you do directly nitration on aniline, it forms anilinium ion. Anilinium ion is a meta-directing group, so it give meta product also. Hope you remember 51% para, 47% meta, 2% is ortho. Yes, so even though aniline is a ortho-para directing group, it's giving a substantial amount of meta product also because of the formation of anilinium ion with acidic medium. In acidic medium, aniline get protonated, forming anilinium ion. Yes, you know aniline react with the strong acidic medium, forms what? Anilinium ion, that is what? NH3 plus. It's a meta-directing group. So both correct and correct explanation, right? Next one. Assertion. Propylamine. What is propylamine? CH3, CH2, CH2, NH2. Propylamine on reaction with nitrous acid. What is nitrous acid? HNO2. It forms aliphatic diazonium salt. Aliphatic diazonium salt. What is aliphatic diazonium salt? N2 plus and Cl minus. You know, it's actually unstable at a high temperature, so it immediately reacts with the water, forms alcohol. Yes, that's correct one. Reason, aliphatic diazonium salts are stable at 273 to 278 Kelvin. So they are actually what? Unstable at that condition, right? Aliphatic diazonium salts are unstable, so immediately it react with what? Water, forms what? Alcohol. So this will be unstable, immediately react with alcohol H2O and forms which one? Alcohol. So assertion is correct, reason is false. See. So aliphatic diazonium salts are stable at 273. No, aromatic, that's only one stable. Which of the following sets have all the compound with a pKb value more than ammonia? So ammonia is there. You know how pKb value? pKb value inversely proportional to what? Basicity. Correct? You know aliphatic amines, right? Aliphatic amines are, we know the order we studied that. Aliphatic amines are more basic than ammonia, and aromatic amines are least basic than ammonia. Correct? So the question, which of the following sets have all the compound with a pKb value more than? pKb value more mean least basic. Least basic than ammonia means they should be aromatic. Can you take it? Which all are aromatic, dear? Only fully aromatic. Fully aromatic is in which all system? I will select B. See, aniline, aniline, aniline. Aniline is what? Aromatic. Aromatic amines are least basic than what? Ammonia. Because you know, in aromatic amine, the lone pair is not available for protonation. Correct? Next one. Two isomers. What are the two isomers given? C4H9NH2. What is C4H9NH2? CH3, CH2, 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 NH2, butanamine, and CH3, CH2, NH, CH2, CH3, N-ethyl ethanamine. Have molecular formula. See, they are isomer, right? Yes. Which of the following is correct about this, their boiling point? Okay. Can you tell me their boiling point before going to the option? It is a primary amine, it is a secondary amine. What is the order of boiling point? Primary greater than, secondary greater than, tertiary. So no doubt this one having greater boiling point because it can form more number of hydrogen bond. Answer. Boiling point of first is higher than. No doubt. That's the correct answer, right? Which is correct they're asking. Boiling point of first one is higher than the second one because it's primary, it's secondary. Next. Benzene sulfonyl chloride. What is that? That's our Hinsberg reagent, right? Benzene sulfonyl chloride is a chemical which can be used to identify the class of amine. Yes, it is used to distinguish between primary, secondary, tertiary amine. When an amine A react with the Hinsberg with the benzene sulfonyl chloride gives a precipitate of sulfonamide, which is soluble in alkali. We studied when a primary amine react with the Hinsberg, it give a product which is soluble in alkali. So A is what? A primary amine. The amine A is. Which is a primary amine, dear? N-ethyl ethanamine. What is N-ethyl ethanamine? This is what? N-ethyl ethanamine. It is a secondary amine. Not our answer. N-diethyl is what? Tertiary. Ethanamine, no doubt. What is ethanamine? C2H5NH2. Yes, that is the primary amine. So primary amines react with the Hinsberg. It's give a product which is soluble in alkali because it contains one acidic hydrogen. Okay, next one. 2-methyl-butanamide. 2-methyl-butanamide. What is 2-methyl-butanamide? This is butanamide, right? This is butanamide. Sorry, that's a butanamide. This is what butanamide. In which second position methyl group. Okay, this is what 2-methyl-butanamide. Okay. 2-methyl-butanamide on reaction with, what's that? Bromine and alkali. Bromine and alkali. What is this reaction? How do you get it out? What is this reaction? Amide when react with the bromine and alkali, that is our Hoffmann bromamide degradation reaction. Okay, alkaline medium gives an amine. How we write the product in Hoffmann? Just cut the CO group. What is left here? CH3, CH2, CH, CH3, NH2. You are getting butan 2 amine. Which of the following is a correct characteristics of that amine? What is the, which is correct about this amine? Let's see. It is an optically active compound. Check it, is it contain chiral carbon or not? Yes, it contain. Is this carbon chiral? This carbon connected to ethyl, hydrogen, methyl and amine. Yes, it is chiral in nature, so optically active. It is a secondary amine. No, it is a primary amine. It can form a stable diazonium salt. Since it is aliphatic, they are forming unstable salt. It can form a, okay, it has one carbon atom more than the amide. No, always during Hoffmann, one carbon less in the product. So only answer is A. When benzene diazonium chloride, what is benzene diazonium chloride? Benzene with what? N2Cl. When benzene diazonium chloride treated with the fluoroboric acid, what is fluoroboric acid here? HBF4. You know what happened? This H and Cl go out, you get benzene with N2 plus BF4 minus. You will get benzene diazonium tetrafluoroborate. Okay, next. So for compound gives a compound X. So this is what? Your compound X. Next. Identify compound X. This is a compound benzene diazonium tetrafluoroborate. When question A is over, what is B? When compound X is heated alone or with NaNO2 in the presence of copper, it releases N2 gas. What are the other two products formed when compound X is? Dear, if you heated this compound with what? NaNO2 copper, right? If you directly heat this compound, you will get fluorobenzene. But if you heat it with NaNO2 and copper, what you get here? You will get nitrobenzene. The nitro will come to benzene. The N2 gas come out, right? N2 gas come out and Na combined with the BF4 will get NaBF4. So these are the other two byproducts. So when compound X heated alone or with NaNO2 in the presence of copper defines N2 gases, what are the other two products formed? What happened if you directly heat this one? Only heat. Only heat if you did, what happened? Fluorine you will get. That's our Ball-Schiemann reaction. You will get fluorobenzene. Okay, one of the fluorine comes here and N2 gas will be there, BF3 will be there. These will be the byproduct when you only heat. This is what heat with NaNO2 and copper. Okay. And what are the other two products formed when compound X is heated alone? If you heated alone, the other two byproducts are N2N, BF3 and fluorobenzene is the main one. Heated with NaNO2, if you heated nitrobenzene, N2N, NaBF4. Write the chemical equation involved in this reaction. Hope you get it, that concept. Next. Anushrita was measuring the pKb of two compounds A and B. She recorded the observation. Okay, pKb here, pKb here. Here pKb less, that means this is more basic and this pKb more, so it is less basic. Correct? Next. Which test tube is expected to contain benzylamine? What is benzylamine? Benzene with CH2 NH2. Benzylamine and which is expected to be aniline. Can you tell me, dear? Which is most basic among this one? Since this is an aliphatic amine because NH2 connected to CH2. So this lone pair is available for protonation. It's more basic. But you know, this is aromatic amine, lone pair involved in resonance, not available. So which is more basic? This one. More basic mean less pKb. This is least basic, so what we can say, more pKb. So more this is less pKb means here, this is more pKb here, right? So connecting the basicity with which one amines. Next question. Of the two compound P and Q, which one is more likely to be acidic in nature? This is actually our amine reacted with the benzene sulfonyl chloride. Okay, this is a carbonyl group is there. See, this part is same, right? This part is same. What is the difference here? You can see. This is benzene sulfonyl part and this is what? A carbonyl part. Dear, sulfonyl group is more electron withdrawing groups than a carbonyl group. Since sulfonyl group is more electron withdrawing, it makes this hydrogen more acidic. So this is the one more acidic than this Q. So P is more acidic than Q because sulfonyl group is what? More electron withdrawing than a carbonyl group. Ready? Next question. Identify the type of amine MNO in the flow chart. 3 test tubes are there. That is M is there, N is there, O is there are taken. Okay, 3 test tube. Okay, 3 test tube they taken. One contain M, one contain N, one contain O, M and O. First they are adding CH3COCl. You know, amines when react with the acetyl chloride, what do you get? Amide. It becomes what? Amide, right? It's become amide. If it want to react means, if a amine reacting with the acetyl chloride mean it should be a primary or secondary, because tertiary amine not contain hydrogen, it do not react. Okay, so if it's giving amide means that that should be primary or secondary amine must be there. Okay, it is a product formed no in test tube N. So test tube N, no, nothing is happening for this one. So that means it is a tertiary amine. So N is a tertiary amine because acetyl chloride react only with the primary and secondary amine. So it is confirmed M and O are which one? Primary or secondary. So N already we identify. So no test tube N, no reaction. That means it is a tertiary. Okay. Now, so this is, it can be M or O can be this compound. Okay, let's see, let's continue. Test tube MNO, yeah, already given. Test tube MNO. Okay, to the test tube MNO, what they are adding? They are adding chloroform and KOH. What is this reaction here? Carbylamine reaction. Carbylamine reaction only given by what? Primary aliphatic or aromatic amine. So it should be a primary amine. And is a false smell product formed. No in test tube M. No in test tube M means what? M is the secondary amine. Secondary amine. Yet yes, it is formed in test tube O. So test tube O is a primary amine. See the way of questions. Interesting, right? So remember all. Acyl chloride, acylation or acetylation we are doing on primary, secondary amines because there is only hydrogen is present to remove the Cl. So tertiary amine do not react. And the remaining MNO to which they are adding carbylamine test. Carbylamine test is given by only primary amine. So O is giving the test. So O is a primary amine. In M it's not happening. So M is the remaining secondary amine. Hope you get it. So these are the questions from the chapter Amines.